Hello and welcome. This lecture is based on finding the square roots of non-perfect square numbers. We have to find square root of 1387. Since the last digit is 7, so this number is not a perfect square number. That means this is going to give us square root which is non-terminating and non-repeating. So we have to find square root up to 2 decimal places only. As before, we will group these numbers and we will separate first group from rest of the numbers. The technique is same. We have to find a perfect square number below 13. 9 is the perfect square number below 13 and its square root is 3 and double of the square root 3 is 6. 6 is divisor for this calculation. If we subtract 9 from 13 we get 4 and we write this 4 before the next dividend number. So next dividend number is 48. Now we have to divide 48 by 6. 6 can divide 48 8 times and we get 0 as the remainder. 7. Now we have to subtract duplex of 8 from 7. But duplex of 8 is 64, which is bigger than 7. So we cannot divide 48 8 times. So 6 can divide 48 7 times. 6 times 7 is 42 and remainder is 6. We write this remainder below the next dividend number. So 67 is the next dividend number. We have to subtract duplex of 7. 67 minus 49 because 7 square is the duplex of 7. This gives us 18. But this number is not a perfect square number and we have to find square root up to 2 decimal places. So we will place a decimal and zeros after this number. So we will keep on doing this calculation till we get 2 decimal places. Now here we will have decimal place after 37 because there are 2 groups. So we will place decimal after 2 digits. Now 6 can divide 18 3 times, but in that case we cannot subtract duplex of 73 from 0. So that means 6 cannot divide 18 3 times. So 6 divides 18 2 times. Now 6 times 2 is 12. So 6 is the remainder. We place this 6 before the next dividend number 0. So next dividend number is 60. Now we will subtract duplex of 72 from 60. Duplex of 72 is 28. So we subtract 28 from 60 and 32. Now we will divide 32 by 6. 6 can divide 32 5 times and 2 is the remainder. We place remainder before the next dividend number. But duplex of 725 is more than 20. So that means 6 cannot divide 32 5 times. So 6 divides 32 4 times. 6 4s are 24. 8 is the remainder. So next dividend number is 80. From 80 we have to subtract duplex of 724. Duplex of 724 is 56 plus 4 which is 60. So we subtract 60 from here and we get 20. We just have to perform calculations up to this digit because we want square root up to 2 decimal places. So we have to go up to 3 decimal places. Now we have 20. 6 can divide 20 3 times. 18 and 20 is here, but from 20 we cannot subtract duplex of this number. So 6 can divide 20 2 times. 6 times 2 is 12. So 8 is the remainder. Now we don't need to perform further because we need answer up to 2 decimal places only. And 37.242 so on. And now there is 2 after 24 and rounding of value for this answer is 37.24. So square root of this number up to 2 decimal places is 37.24. This is also a non-perfect square number and we have to find square root of this number up to 2 decimal places. because there are 4 groups, so there will be 4 digits before decimal place. Now, perfect square number below 52 is 49. So we write square root of 49 7 over here and double of 7 14 as a divisor. Now if we subtract 49 from 52, we get 3 and we place this 3 before the next dividend number. Now next dividend number is 34. Now 14 divides 34 2 times, 28. If we subtract 28 from 34, we get 6 and we place this 6 remainder before the next dividend number. So next dividend number is 64. From 64 we will subtract duplex of 2, that is 4. So 60. Now 14 can divide 60 4 times, 56. If we subtract 56 from 60, we get 4 and we place this 4 before the next dividend number. So next dividend number is 43. From 43 we subtract duplex of 24, that is 2 times 2 times 4, 16. So if we subtract 16 from 43, we get 27. Now 14 can divide 27 one time. 14 times 1 is 14, so remainder is 13. So we place remainder 13 before the next dividend number 139. From here we have to subtract duplex of 241, which is 2 times 2 times 1 plus 4 square. That is 4 plus 16, 20. So we subtract 20 from 139. So 119. Now 14 can divide 119 8 times. 14 times 8 is 112. So 7 is the remainder. We place 7 before the next dividend number. Now from 70 we have to subtract duplex of this number, which is 2 times 2 times 8 plus 2 times 4 times 1. This is 32 plus 8, which is 40. So we subtract 40 from 70, 30. Now 14 can divide 32 times, 28, and 2 is the remainder. But 27 is smaller than duplex of this number. So 14 cannot divide 32 times. So 14 can divide 30 one time, 14, and remainder is 16. So next dividend number is 167. Because there are 4 groups, so we have to place decimal after 4 digits. So we are reached up to 2 decimal places. We just have to perform calculation up to 1 decimal more. Now we have to subtract duplex of this number from 167, which is, this is 4 plus 64 plus 1 is equals to 69. So we have to subtract 69 from 167. This is 98. 14 times 6 is 84. 14 can divide 98 6 times, 84, and 14 is the remainder. From 140, we have to subtract the duplex of this number. Let's see what is the duplex of this number. "48". So we will subtract 48 from this number, 92. But we don't need to perform further calculations because we have to find answer up to 2 decimal places and we already did the calculation up to 3 decimal places. So rounding off value for this answer is 0.82 because the next number after 1 is 6, which is more than 5. So rounding off value will be 7241.82. So square root of this number up to 2 decimal places is. So this is how we can find square roots of non-perfect square numbers. And now there is a small task for you to practice more problems. Answers are also given to you.